So now you can see that we can freely edit those grids, and if you're watching on the right hand side, our full arrangement will move with those grids. So this is a really intentional way of modeling that will save you a lot of time and a lot of energy. How to model parapets, gutters, roofs, all that kind of stuff in Revit intelligently, or maybe more appropriately, intentionally. This tutorial, very quickly, is just to show you modeling practices basically, so that you can not only be informed on how to create, let's say, a parapet and full roof construction for something like a Kingspan building or a Tegral building or something like that, where you have cladded panels on a parapet arrangement. But outside of the actual modeling practices, it's more about the intentional considerations on how you can actually control change management at the later ends of the project, so that if there's any variation to the building footprint, all these changes are nearly automated and they save you a lot of grief and a hell of a lot of time. Okay, so as always, I'm Niall, this is 8020 BIM. If you like this content, you know what to do down below. Do like, comment and subscribe, all that good stuff. Just so you know, all resources in the video are outlined, available to download below, and they're free to 8020 BIM members. And there's also a 8020 BIM Discord community channel, which is completely free for everyone to join. And it's just a place for people to go, sit tight, have a chat, talk about things, all things Revit, ask questions and all that good stuff. Okay, so I won't delay any further. Let's get straight into it, and I'll talk through how you should model your parapets, or at least one way to do it. So to begin, I'm going to start by building the stacked wall arrangement that I'm going to use for the parapet. Now, you can use other wall arrangements rather than a stacked wall arrangement. You may wish to have the outer leaf and the inner leaf of the parapet construction as independent walls, so that you can vary the width across the parapet. But in this instance, I understand that the parapet is a uniform dimension across the entire project, and therefore I'm going to use the stacked wall arrangement. So going into the Revit view here, you can see here's our sample model, okay? And the first thing I'm going to do is I'm going to create the stacked wall, okay? So just to give you an overview of the wall types that we have available already in this file, you can see that when I go into my edit type here, we have basic wall, a parapet wall, and the parapet wall, you can see that I have both the exterior cladding and the interior cladding for the internal rising of the parapet wall, okay? Outside of that, I also have a sandwich panel wall as such for the outside leaf of the cladding, okay? So rather than using the basic wall families, on the actual drop down, you can see that there's a system family stacked wall. And when I select that, you can see that I've already created a stacked wall in view here, okay? And on the stacked wall in view, when we go to edit the structure, okay, you can see that we have the outer leaf, as I described as the sandwich panel, okay? And that's set to a height of variable, which means if we're going to, from let's say the ground floor to the top parapet level, okay, and then there's any variation in that parapet level, that lower part is the part that's going to vary, not the upper part. So what we're doing is under the parapet wall section that we've stacked, we're actually giving it a height, a known height that we know is going to work. In this instance, it's about 1220 mil. I might be able to edit that afterwards if required, okay? But you can see it's about 1220 mil. And you can see I have an offset of 152.5. And that offset of 152.5 is just to give me an external alignment, okay? But we could actually change the alignment to finish face exterior here, and I could give that an offset value of 0. Sorry. And it wouldn't go all the way. I'd still have to give it a value of 100 mil or negative 100 mil. And you kind of get a feeling for the kind of adjustments you have to make, okay? We could also go finish face interior and set that to 0. And you see it's the same situation, except on this side we're on the reverse side of what we want, okay? So I'm just going to cancel all that because I was happy with my original arrangement, and I'm going to press OK. So now we actually have our stacked wall within the project that we can develop, okay? And under here you can see, in order to check it, on the properties on the left hand side, you can see it's called up a stacked wall, okay? So going to our roof plan, okay? We want to draw this stacked wall around the boundary of the building, okay? So going to architecture, wall, okay, or just pressing WA on the keyboard, we have our stacked wall selected, and we're going to select our base constraint as ground floor and our top constraint as top of parapet, and I'm going to leave that as a minus 100. And I'm just going to leave a minus 100 so we can put an insulation above it, okay? And then we can say finish face interior, exterior, core, centerline, core, interior. And So I'm going to say core face interior. Finish face it. Do you know what? I'll adjust this as needed. It's going to be a tricky one because we have the stacked wall, so I'm not going to think about it here now, okay? So I'm just going to leave it as finished face interior, okay? And I'm just going to use my rectangle tool, and I'm going to draw it, making sure that my base constraints remain the same, and that I'm going to my top of parapet minus 100, and then I'm just going to draw from this point to this point, okay? And as you can see, that's actually after offsetting out the way rather than in the way, okay? So I'm going to tab select all that, and I'm going to press enter. I'm going to press return or spacebar, sorry, and that's going to flip the orientation. And then finally, I'm just going to give that another offset value. So I'm just going to select numerical, 100 mil, perfect. And I'm just going to offset that value. I'm just going to select one wall, and I'm going to tab. So you can see that the boundary walls are completely highlighted. I'm going to select that. And now if I go down to our ground floor, we should see that the alignment of our external cladding there is directly on the outside of the rail. So that is perfect, okay? So when we go up into our 3D view, you can see now that what we have is we have our full stacked wall arrangement rising, okay? And we have our cladding for the interior of the parapet also there. Now there's a few cleanup exercises we have to do with stacked walls. The alignment of the patterns isn't necessarily uniform at all times. So if you just tab, you can use the align tool to select the pattern by face and just lock them together so they don't look off, okay? And the benefit of using a stacked wall is you have a wall that will allow for hosted objects to cut through both leaves rather than just the exterior or the interior. And that's really useful when you're using something like a scupper for a gutter, which we'll be inputting later on. And you can see that it'll actually pass right way through. Now, finally, one of the things I want you to be most cognizant of is the actual setting out of this wall relative to other core kind of setting out datum elements, such as grids, okay? So in this instance, I'm going to make sure that we are actually aligning our outside face to our grids, okay? And then we're going to lock them as we're going, okay? So we're just taking dimensions all the way around, and we're going to lock them to our outside face from the grid, okay? And this is so, should we have a building set out change on the boundary and our grid setting out is updated, we don't need to go and take all the individual roof elements, the parapet wall, the parapet capping, the gutter, all of that, and manually change them. All we need to do is vary the grid, and everything should move with the association to the grid, okay? So that is part one, which was how to create the cladding wall inclusive of the internal parapet, okay? And the next part we'll actually dress this up a bit, and we'll develop out the actual parapet capping on this, okay? So before we go ahead and populate the likes of the gutters and the parapet capping and the parapet insulation and that kind of thing, what we need to do is we actually need to create our roof. And what I want to do is I want to make sure that we've created our roof so that we've locked the extents of the roof, the bounding extents of the roof, to the wall geometry adjacent. So when our grids change, our walls change, and our roof stretches accordingly, okay? So looking at the screen here, you can see that I've already undertaken one half of the roof. And what I'm going to do is I'm going to talk through how I set out the second half of the roof, okay? So going to our roof plan here, I'm going to go to the architecture tab, and I'm going to select roof, okay? And I'm going to use roof by footprint. I'm going to use our Kingspan Topdek, and I'm going to set the base level here to our eaves. And I'm not going to give it a base level offset. And the reason for it is I don't know the exact offset value. I want it to snap to the top of the purlins, okay? So rafter cut, plumb cut is perfect. And we're just going to start drawing our boundary line, okay? So the first thing I'm going to do is I'm going to select our rectangle here. And I'm just going to give this an offset value of 100. And the reason I'm going to give an offset value of 100 is I don't want to draw the exact boundary where its final position is going to be. I'm going to use dimensions and alignments to lock the boundary into known dimensions that I want. So what I want to do is I want to draw it with an offset value so it's not stuck to anything yet. I want to be intentional about actually forcing the alignments and the dimension locks. So going to the internal side of our wall here, okay? I'm just going to press spacebar just to flip that offset onto the interior, okay? And then I'm going to come down here to this grid intersection with the inside face of the wall, okay? Now, this is a dual pitch, but it doesn't have a hip at either end, okay? We have a gable wall at either end. So I'm going to select the gable ends and I'm going to turn off define the roof slope. And then I'm going to select the actual sides that dictate the pitch of the roof, and I'm going to change the slope to 6 degrees to match the structure below, okay? Then what I'm going to do is I'm going to use DI for dimension, and I'm going to dimension this boundary line to the inside face of that wall, okay? Oh, apologies. Let me go catch that again. I'm also going to do the same on the reverse side to the grid, okay? Now, what we can do is we can use these dimensions to drive our definitive offset for our gutters, okay? So, on the midpoint, I want the midpoint gutter to be 600 wide. So I'm going to give this a value of 300 here from the center line of the grid. So 300 on one side and 300 on the other side, okay? And then I'm just going to select that dimension and I'm going to lock that dimension to the grid. Similarly, on this side, I want this to be approximately 550 mil, let's say. And again, I'm going to select that and I'm going to lock it, okay? And the important thing about locking that is I've locked that now to the interior face of the parapet internal wall, okay? And that means that if the grid changes, the wall changes, and our roof will spread and contract accordingly, all right? Which means we don't have to go and edit the roof footprint each time. Finally, I'm just going to use the align tool to align to the gable walls, and then I'm going to lock the boundary. And then again, I'm going to do the same on the reverse end here and select the boundary line and lock, okay? And now I'm going to finish. And you can see now that we've created the second half of our roof, but we don't necessarily have the exact level, the offset value that we need. So going to our 3D view here, okay, I'm going to turn on the section box. And I'm going to, just for a bit of depth there, I'm going to drag that down here, okay. And looking in view here, you can see that, here's the roof we created, and you can see that our offset value is not correct. So I'm just going to use the move tool to the underside of the roof, and I'm going to say that's 27.1, perfect, okay. And now you can see it's aligned perfectly to the top of the purlin run on either side of the roof, okay. So now we've gotten to the point that we have modeled both our clad walls, okay, for the exterior leaf, our interior parapet cladding, as well as our dual roofs that are now tied to both the median grid in the middle of the building and our parapet internal walls, so that should the building setting out vary at all, our entire parapet build-up as well as our roof construction should flex accordingly, okay? So now we get into some of the more fun elements that we can kind of see the expeditious modeling methods here, okay? And what I'm going to do now is we're going to develop our gutters out. So we're going to model our gutters, we're going to model our associated scupper to take the water away, as well as the downpipes on the outside face of the building, okay? So looking at the roof that we've built so far, you can see that we have our parapet and our roof exactly where I left in the last step, okay? Now, when I go to roof drop down here, I can select gutter, okay? And you can see that I've got gutter underscore parapet box. Now, in a previous video, which you can get from the eye in whichever corner it is, you can go and watch that video where I create a full parametric box gutter profile family for you to use in your projects. And there's also a download link in the description below should you want to just go and get that independently and not worry about creating it from scratch. But the good thing about the parametric gutter profile is we can change the values of the depth and the overall width and that kind of thing within the live project environment without using something like an in-place extrusion or having to go into the family each time and make manual edits. We can just do it directly within the project browser. So I've selected the gutter, and I'm just going to select the leading edge of the roof on this side, and again on this side, okay? And I'm going to go ahead and I'm going to turn on my section box again, and we'll click and drag it down here, and we'll have a look at what we're looking at, okay? And as you can see, that gutter actually is fairly close to what we need on our boundaries there, okay? Now we have a variation of 550, I believe, between here. So what we need to do is change the the gutter itself to suit our particular constraints, okay? So I suppose the first thing we're going to need to do is we're going to need to go down to our gutter profile itself and start making edits to the profile reporting values so that it works in this context, okay? So I'm going to press DI here, just very quickly in 3D, and I'm going to measure the distance between these two. So our gutter, I think, needs to reduce. It actually doesn't need to reduce. What it needs is an offset value, I think. It'll reduce, if I reduce that 50 mil, I think it'll be suitable, okay? So go into our parapet test gutter here, okay? Oh, sorry, that's a parapet, apologies, our box gutter family. You can see that here is the profile that we're using as the gutter in this instance, okay? And we want to go through changing this value. So looking at the overall gutter width, I said we want to reduce it by 50 mil. So I'm going to change that gutter width to 580 mil. Okay. I'm going to press OK. And you can see that that value is after shrinking. Okay. I'm also going to go in here and using the actual profile offsets, I'm also going to select the other one at the same time. It's good it's selected both because I'm editing both at the same time. Just so you know, there was an error there when I created that. I created the both gutters at the same time. I should have broken the command so I had independent gutters on each side, but it's fine for this example, okay? So I'm going to give it a horizontal offset of 10 mil, of 20 mil, let's say. And I'm just going to give it a 2 mil profile there, okay? I'm actually going to change that to -20. Okay, and what I wanted was I wanted a slight lap between our roof construction and our gutter. Our gutter shouldn't emerge from the joint. There should be a slight lap. So if you imagine that you'd have some sort of flashing profile coming down or some sort of corrugation on the roof coming down and out, you'd have a drip, and you don't want that drip to be right at the join of the gutter. You want the gutter to be offset back, okay? So now we're starting to get there, and what we actually have here is we have a small variation here at the back, okay? So this here is, if I press DI, if it'll let me, not going to let me take these points. Give me a second there. I'm going to go to our section. And forgive the presentation of the section here. I'm going to set that to fine. I'm going to press DI. We've got 8 mil variance there, okay? That's okay. So in this instance, what we need to do is we need to change our stacked wall and we need to reduce the overall value of the top stack by 8 mil. Okay, so going into edit type, I'm going to edit the structure here, and on our stacked wall, I'm going to change that to 1, 2, 2. Okay, I'm going to press OK. Okay, and you can see now that that joins perfectly. So what we have is we have a little 10 mil offset between our outside inner face of the cladding, the parapet, okay, and the gutter line. And again, that's so we can have a drip profile and to make sure that water doesn't lap in, okay. So that is our boundary gutter modeled on both sides. And as we had a joined boundary from one side to the roof to the other, as we have, what we've done is we've made those edits on both sides. The reason the edits were successful on both sides is because we were using the same profile as well. So even if we had broken the command when placing the gutter, we would have had two independent gutters, but they still both would have updated because we were updating the profile reporting values, okay? Finally, we have the mid gutter here, and I don't have a family for the mid gutter here because the hosting for the mid gutter is a little bit difficult because which roof do you pick? So you could maybe create a gutter profile and create a model line for the mid run of it if you'd like, but I find that a little bit tricky. So in that instance, what I tend to do is on the roof here, okay, I'm going to say roof by extrusion. I'm going to pick a plane and I'm going to pick the parapet wall, okay? On the level here, I'm just going to set this to eaves level roughly, okay? And I'm going to press OK. And now I'm going to draw the profile which we want, okay? So in this instance, I'm going to just draw the profile from, I'm going to change it from Topdek to mid gutter, okay? Because that's a family, that's a roof construction I previously developed. And what we're going to do is we're going to take this down approximately 45 mil. I want it to be 100 deep, so I'm just going to do this. Then I'm going to take a 45 mil, and then I'm going to do the same on this side. I'm going to take a 45 mil until I get the the snap from the other two. Okay. Then I'm going to do this. And then finally, I'm just going to move these about 20 mil again. So I'm going to move this 20. And I'm going to move this side 20 mil so that they're equidistant from the mid-grid. Okay. And finally, just having a quick sanity check there. Oh, sorry, I just want to make sure that we actually extend to meet the underside of the roof above, okay? And I'm just going to press finish. And got to do one more edit on the profile, and I'm just going to drag this. We're just going to draw a little 70 mil return underneath the roof there, so we can close out our profile. Okay. And cut. Sorry, apologies. Square. Yeah, the cut isn't changing the condition there for us. Okay, not to worry. Anyway, you can toy around with that if you need to to change that variable. But what we can do here now again is I can click and drag the extents of this here. Okay, I'm going to turn off my section box, and then I'm going to use the align tool to select the inside face of the parapet wall, and I'm going to select the endpoint. Oh, hold on a second. Revit says no. Give me a second. I'm going to press the align tool. There you go. And again, I'm going to lock that. And on the reverse face, I'm going to do the same on the other gable wall. And I'm going to select that endpoint and it'll expand. And then we just lock that again. Okay. And now we should create our gutters, both at our boundary and at our midpoint across the roof. Okay. And it's all starting to look fairly neat and organized. So finally, what we can do is we can introduce a scupper. Okay, so if I go to component here, you'll see that I have a scupper in place. Okay, and I want to place the scupper on the inside wall here. Okay, and as you can see, we have our downpipe coming out from that. Okay, and what we can do is, because a family has been generated correctly, we can introduce the pipe at the end, and we can give that an offset value all the way down to the ground. So I'm just going to give that offset value to 0. I'm going to press apply. Okay. Routing solution, that's okay. So it's going to give out to me about the routing solution. But as you can see, we have our scupper and our downpipe now modeled. And what we want to do then is go to our roof plan, and we're going to array that. So looking at our previous selection there, I'm going to mirror that across the midpoint. Okay. And again, I'm going to select the scupper and the downpipe. And I'm going to select the scupper and the downpipe. And I'm going to mirror it about the midpoint of this grid as well. Okay. And the problem here is that the scupper is not necessarily going to host on the wall on the opposite side. So I'm just going to have to recreate the scuppers on that side. So again, going over here to turn off the section box, I'm going to press architecture component. I'm going to place my scupper there, and we'll go through the process again of creating our downpipe. So I'm going to say here, and I'm just going to give it an offset value of 0, and I'm going to press apply. It's going to give me that warning. That's fine. Okay, and We'll work on the alignment, so you imagine you'll be a lot more particular, because I'm obviously trying to do this as expeditiously as possible for the tutorial, but you can really focus on your alignments here for your gutter and your downpipe, and then I'm going to mirror that again. Okay, so now what I want to do again is I want to press DI, and I'm going to press DI to the center line of the scupper. Okay, and I'm going to change that value to 250. So we're going from grid to scupper for 250, okay? And then I'm going to press align scupper to, give me a moment. I'm going to align the scupper to the downpipe, if it'll let me. Align the scupper to the, last time. Align the scupper to I'll have to move it into place. Right. And I think that alignment there, I'm not sure if we're going to be able to lock that alignment for the gutter and the scupper throughout. Okay, so what we're going to have to do in this instance is I think we're just going to have to go around all the way. We're going to have to give it our 250 mil value and then manually move our downpipe to suit. Okay, and again, is that 250 locked? So I have to lock the 250 and I have to lock the 250. And again, we're locking it so that when the grid moves, the scupper moves with the full arrangement. Okay. So pressing DI again. We're going to go to our scupper and I'm going to change that to 250. And again, we're going to select the dimension and we're going to lock it. And finally, I'm just going to move our pipe back into place. And one last time on the opposite side, I'm going to press DI. I'm going to select our scupper again. I'm going to move that to 250 mil. I'm going to select the dimension, lock that, and finally move our downpipe. Okay. So now we have fully modeled our parapet walls, including the external cladding and internal cladding, our roofs, our gutters, and our downpipe and scupper arrangements on either end. Okay, and again, these scuppers can rotate onto any point in the roof because obviously you'll have some sort of internal crickets on the roof that are very difficult to model. The only way I can really suggest modeling them is to create smaller roofs to falls within the gutter footprint. I actually personally think that's over modeling, but look, it's up to yourselves. You can just use a notional element that will dictate what you want the falls to be, and you can put in the manual value on your plan view. But now we've actually closed out our first pass of our roof drainage, and again, we probably need scuppers obviously on our internal now that I think about it. That would help, wouldn't it? So I'm just going to go down through here and selecting the elements that we have. I'm going to bring them all the way across and attach them to our mid-grid here. Okay, and again, I'm going to align the scupper to that grid, and I'm going to lock, and I'm going to align the scupper to that grid, and I'm going to lock. Okay, so our roof drainage now is complete. Okay, so next thing we need to do is we need to put in our parapet capping and our parapet insulation. So adding our parapet capping and parapet insulation can be done in multiple ways, and I actually have a full detailed video on this as well. If you go to the eye, wherever it is, we have a full detail that specifies how to create the parapet capping family. Again, the profile family, that's parametric, and we can edit on the fly within the Revit project, as well as the methods of placing both. Okay, so what we can do is we can apply the parapet capping to the wall construction, the wall assembly, as a profile, a sweep on top. Okay, or we can do it as an in-place component. Okay, in this exercise, right, what I recommend is you go and watch that video in full if you want to get into nitty-gritty, but in this exercise I'm going to show you both methods, because I'm going to do the in-place component for the installation, and then I'm going to actually apply our parapet capping to our wall assembly here as well. Okay, so going back to the model, the first thing we're going to do is we're going to start with our parapet insulation. Okay, so on architecture, on the component there, I'm going to say model in place. Okay, and down here I'm going to scroll down, I'm going to select walls, press OK. Okay, here I'm just going to label it parapet insulation. I'm going to press OK, and from there I'm going to use the sweep tool. Okay, and then I'm going to pick path, and on 3D edges I'm going to select the internal line of our parapet wall. Okay, and then I'm going to use TR to trim that boundary all the way through. Okay, now that I've created the path that our extrusion is going to go around, I want to actually create a profile for that extrusion. Okay, so in our edit profile here, I'm going to select a rectangle, and I'm going to go from here to here approximately, okay? And I'm just going to press AL, and I'm going to align that there. And actually, I didn't want that. I'm going to remove that there. And now I'm just going to select this interior corner. I'm going to unselect that reference, and I'm just going to move this value down by about 15 mil. And yeah, I think I'm going to move that overall line down about 10 mil as well, okay? Just to give my my capping a bit of room, okay? So this is loosely the profile that we're going to have for our insulation across the roof, okay? And you can see that this is 2 falls. So we want our parapet capping to be to fall so that our roof falls off the parapet capping, down the face of the wall, and via the drip straight into our gutter and out to our scuppers, okay? So pressing OK, and then going to finish that. And now you can see that we have our full parapet insulation modeled all the way around the suite, okay? Again, I'm going to, because we use the 3D line selection tool on the inside face of our walls, if the grids change, the walls change, this arrangement also changed accordingly, okay? The one thing I want to also do is make sure that we have parapet insulation as our, yes, okay, so we have the correct material assigned, perfect. So I'm going to press finish model there. And now we have our insulation in place for our roof, okay? So when I pull up a section here and I pull the section down through the building, you will see that we have our full insulation build up there. And similarly, you can do the parapet capping in the same manner, but I'm going to show you the alternative way of doing the parapet capping now as well, okay? So selecting our full stacked wall, okay? If I go into edit type here, you can see that I can't actually apply anything to the top of the wall from within the stacked wall properties, okay? So what I need to do is I need to cancel that, and I need to go down to our, when I go to edit type, under the family stacked wall at top here, I need to change that to basic wall, and then I need to select our internal parapet, okay? And you can see that I've got my parapet there with a profile already assigned to it, and that's the one that I'd use if I was having both the external cladding and the internal cladding as independent walls. But in this instance, we're using a stacked wall, so it's one wall, okay? So what I want to do is I want to go down to the top part of that stack, which is this wall here. And under the edit structure here, we have to make sure that our section preview is visible. So you might be looking at this window here. So what we need to do is we need to go to preview. And if you're looking at the floor plan here, you won't have any of these options available to you. So what you need to do is you need to actually go to your section, and then the modify vertical structure elements will come available to you, okay? And in the top right corner of those options, you can see we have sweeps. So when we press sweeps here, okay, we can add, and under the profile here, I'm going to select Parapet Profile Test Family, okay? So this is the family that we created in the previous video where we talked about how to create the parametric parapet capping family, okay? Material here, I'm just going to select aluminium or aluminum, depending on what part of the world you're from. And I'm going to set this to the top, okay? And I'm going to press apply, and this is probably going to look a bit odd on top of the wall here, okay? And as you can see, it's actually taken it from the outside face out, okay? So again, I'm going to go to our offset value, and I know that this total wall buildup is 405, so I'm going to set that as 405, and I'm going to press apply. And you can see it's gone the opposite direction, so I'm going to set that as a negative 405. I'm going to press apply and press OK. Okay. And when I zoom into the top, you can see now that that's perfectly enclosing the wall construction that we have. Again, that profile is parametric, so if I press OK, press apply and OK, you will see that we have a profile that's appearing all the way throughout on these walls. There is one problem, however, though, and that is that the orientation of that is incorrect. We need to change the orientation of the parapet wall itself, okay? So looking at this all the way around, we kind of have a situation that's a bit confused because we have our parapet going in the right direction on one side and the wrong direction on another side, okay? So I'll need to actually finalize that. But what we actually have here as well is an error on my behalf because I changed the wall type because I had the wall type previously selected. So what we want to do is I want to undo that, okay? And when I undid that change, it maintained the new capping on the family, but it changed the wall back to the default wall I should have. And now you can see that our capping is correctly oriented all the way around. Okay, so that is my preferred way of modeling a parapet capping if you have something like a stacked wall, as we have in this instance. If we had separate walls, I may consider not doing this because I'd only be applying the capping to one leaf, and that can be a little bit kind of temperamental. We could end up in a situation that we have a variation between the leaves and our capping has to vary, but we've only got the internal wall, let's say, has the capping sweep on top of it. You can't vary that per instance then, okay? It would be a type property that would drive the whole thing. So in which case you might need to do part wall capping extrusions all the way around. Just so you know as well, just to mention that this is a parametric family here, and it's available in one of the, I think it's the third download link below. We can actually change the overall setting out of this so that very quickly we can change the presentation of our capping throughout our model, okay? So looking at that, that looks fairly neat and together, and we do actually have to make one small change there just to lift it above our insulation value. So on our front height there, I'm going to change our front height to 210, and I'm just going to press OK just to see what happens there. That didn't make the change that we needed to. So capping front height, capping rear height, outer face offset. Bear with me one moment. Oh, sorry, cap height above the wall up front. I'm going to set that to 100. Okay, and I'm going to press OK, and now you can see it popped up. Okay, so again, you need to get in and have a look at that family and see how the parametric functions work so that you can correctly manipulate it. But as you can see, we've got our full capping profile there as part of our overall wall construction, and we now have our insulation in place. So the reality is that is our roof construction somewhat finalized. You know, we have developed everything. We've done it in a very quick manner, but we've also done it with considerations to change management, so that if at any point our outer boundary changes, all we need to do is flex the grids and the whole associated buildup should actually function. So what I'm going to do now is I'm going to set up a view, and I'm going to come back and I'm going to show you how, by changing the grid locations, our overall wall construction and our roof construction with the parapets and the gutters and the insulation should also update accordingly. So I just went ahead and set up views there so we can test how the overall setting out controls are working, and just to do a sanity check to make sure that it is in fact parametric and it is in fact flexing the way we need it to, so that we can minimize the amount of potential rework that we have to do at any given point in a project. Okay, so looking at this arrangement here on the right hand side, you can see that we have this corner G9 intersection, and that's just hosted in that corner there. Okay, and what I'm going to do in this instance is I'm actually just going to go into our visibility graphics, and under the Revit links I'm just going to turn off that in the view. Okay, and I'm just going to do the same over here on this one. So I just want to focus on the architecture here. Now you can use copy monitor as a means of staying in touch between your links. So if you have your grid set out in your structural model and you've copy monitored your grids to the architectural model, when the structural model grids update, you'll get flagged in the architectural project and vice versa. Okay, so this works on the structural side of the fence as well, where you can have your columns are obviously placed on grid intersections, but then your offset values for them, for the likes of your rising parapets and your purlin start points and that kind of thing from the beam systems, this can be locked in the same manner, so it'll all flex accordingly. Okay, so looking at this here now, I can go and start to flex this this construction here. Okay, so looking at G9, okay, I'm just going to turn on that grid bubble there. Okay, so let's test 9, and what we're going to do is I'm just going to move that back towards this grid, and you should see constraints are not satisfied. That's okay, that's a different constraint, but you can see that the whole arrangement moved accordingly. Okay, similarly, if I move 9 back, it's going to give me the same warning, but it's just telling me that there's a constraint there somewhere that's breaking, and that's good to know because that'll highlight. Similarly, when I take G, okay, I can expand that out, and you can see that the whole assembly moves, including the pitch. So our apex of our roof will actually increase in height if we stretch the walls out, because we've maintained our association of the roof to the inside face of the wall via the 550mm offset that's been locked. Okay, and then when we expand out the building, the pitch stays the same, so that the roof ends up, the apex ends up coming up, you know. But you can see that in this instance, even though we changed the grid, and that warning in the corner was the copy monitor warning I was telling you about, even though we changed the grid, all the elements were correctly associated. So our profile is part of our overall stacked wall. Our stacked wall is associated to our grid by a known dimension. Our insulation is aligned to the inside face of that stacked wall on the inner parapet. Our roof is driven by a dimension value between the inner parapet wall and the edge of the boundary of the roof, and therefore our gutter, when it's hosted to the edge of the roof, will move accordingly as well. And our scuppers are given an offset dimension to the grid as well. So as you can see, this is the intentionality you need to embed into your modeling exercises if you want to really be proficient, and if you really want to help out your teams or your colleagues, because change management is a real pain point for the industry. It's really just, it's something that not only is it difficult from both a client management perspective, and particularly for contractors, you know, it can be costly and it just extend times and that kind of thing. Even for consultants in the design side of things, you don't want to be spending a day neatening models from just a simple boundary alteration to the building. You know, if your building has to get a little bit tighter or a little bit broader, you know, if you model this correctly, that is a 10-minute exercise tops to go around and just change the grid setting out for both your structural, architectural, civil, you know, your MEP models as well. If you have thought about the effects of what you are doing and how you can kind of future-proof your modeling, so that your alterations are fairly straightforward, you know. So look, rather than ranting at you anymore, that's it. That is how I would go about modeling a parapet, complete with parapet capping and insulation and the roof and the gutters and all that stuff, so that you can really negate the effects of change management and just to improve your overall efficiency. As ever, the models are available in the download links below. Please pop onto the Discord community that we have over there for 80/20 BIM. I'd love to see you over there and have a chat and talk about all things BIM and ask questions and all that kind of stuff. It's what it's there for. And we've got a couple of enthusiastic users over there at the moment as well who are very helpful as well. So make sure to go and check that out. As always, I'm Niall. This is 80/20 BIM. Thanks for the support as always, and I'll see you for the next one. Okay, see you. Bye-bye.